Hi friends, welcome to Arnav. So today is the 35th episode in the science series. So in science, today is, guess it, it is chemistry. So in the last episode of chemistry series, we discussed about elemental groups and sets, what they are. So today we are going to discuss about 4 more elemental groups or sets. So first are the lanthanides. Although they were once known as the rare earths, the elements in these sets are not rare at all. So the lanthanides are here in red. So in the periodic table you may see the lanthanides here, but also a red box. A box in that same color as the lanthanides. That is because normally to show the lanthanides we must put them here. But because of there's no space and it would become very wide, they put those down, the lanthanides and the actinides. So the actinides also have the same thing happen to them. So the idea of rarity came from the fact that they are difficult to separate from one another, so they proved to be difficult to find. So these were once known as the rare earths because they are not very easy to separate. So they are actually common but not easy to separate from other elements. So to find them in their pure form, it was very rare. But rare earths was its old name. Its present name is lanthanides. Yes. So next, lanthanum, cerium, praseodymium, europium, holmium are 5 or the 15 lanthanides. So there are 15 actinides and 15 lanthanides. Yes. So next, actinides. A set of elements that are generally very radioactive. So if an element wants to be radioactive, it must be first very active. So that's why this set got its name, actinides. So if you don't know, active and actinide is a very similar words. So that's why we may understand that this is because it got, this name was from the word active, because those elements are very active as they are radioactive. Yes, rhyming. Yes. So the actinides are not found commonly in nature, with a few exceptions. Many of them are only produced artificially and have little use beyond research. So only some of these elements are found in real life. The most famous of the actinides is uranium, which is used in many things, including as a fuel. Yes. While most of the other actinides are produced artificially, including einsteinium, fermium, etc. So some examples of actinides are actinum, thorium, uranium, neptunium, plutonium, einsteinium, and fermium, and there are again some 8 more actinides left. So there are again 15 actinides, and it is just under the lanthanides in the periodic table. Yes. So next, the boron group. So although these elements are all not very reactive, they do differ in other ways. So aluminium has many uses, including in construction. You may have used aluminium foil, which is used for covering things. So aluminium has many uses, while gallium is a metal which is liquid, and also it is not poisonous unlike mercury. It is completely safe unless we eat it. Yes. And thallium is poisonous. Yes. Don't eat it or else you will be poisoned because of thallium. So boron, aluminium, gallium, indium, thallium and nihonium are the 6 boron group elements. Yes. So nihonium was discovered in Japan, and you may have not understand, but its name came from the word Japan in Japanese. In Japanese, Japanmi is called nihon, and also this element is relatively new in the periodic table, being discovered only in 2016. Yes. So yeah. So and also that is an artificial metal. Artificial element. So the next, the carbon group, the last set in this episode. So group 14 includes the non-metal carbon, the semi-metal silicon and germanium, the metals tin and lead, and the radioactive element flerovium, which is also relatively new compared to the other elements in the periodic table. So carbon, silicon, germanium, tin, lead and flerovium are the are the 6 carbon group elements. So, and finally the lanthanides are here and the actinides are here. Next the boron group is here and the carbon group is there, just next to the boron group. So this is for today about the periodic table, elements, groups and sets, part 2. Bye.